Greetings friends, this is Rishab Nahar and welcome to our channel CodeChef. Today we are going to solve a problem, smallest number of nodes. The problem code is FLOW005. This is a simple problem with no prerequisites. Let's move to the problem statement. Consider a currency system in which there are notes of 6 denominations. These denominations are 1, 2, 5, 10, 50 and 100. If the sum of rupees n is input, write a program to compute the smallest number of notes that will be required to give us the sum of rupees n. So the coin denominations that we have are 100, 50, 10, 5, 2 and 1. And using some combination of these notes, we have to create the given input number. And we have to create the number in such a way that we are using the smallest number of nodes. Let's try to understand the problem with the help of samples. So we have a sample. In the given input, we have 3 test cases, which are 1200 rupees, 500 rupees and 242 rupees. For 1200 rupees, it's best to use 12 notes of 100 denomination. For 500 rupees, we can use 5 notes of 100 denomination. And for 242 rupees, we can use 2 notes of 100, 4 notes of 10 and 1 note of 2, which in total is 2 plus 4 plus 1, which is 7 notes. Let us have a look at the constraints. As we can see, there can be at most 1000 test cases, and in each test case the value of sum that will be provided will be at most 10 to the power 6. I would suggest you to pause the video here, think about the solution and try to solve the problem on your own. Let's move to the solution now. So we have notes of 6 denominations. They are 100, 50, 10, 5, 2 and 1. Consider that we need to create a sum of n. We are going to use a greedy approach, and our greedy approach would be to use the note of maximum denomination as many times as possible. That is, if we have a number to be formed which is greater than 100, we are going to use one note of 100. This thing is optimal because instead of using one note of 100, we would have to use more than one note of 50. That is, we would have to use at least 2 notes of 50 or 10 notes of 10 or 20 notes of 5, which is not an optimal solution if we need to find the minimum number of notes required to form the sum n. And now consider that the n is lesser than 100 but is greater than 50, something like 70. In which case, it's optimum to use one note of 50 instead of 5 notes of 10 to create a sum of 50. After we have created a sum of 50 using one note of 50, we are left with the sum of 20. And this sum of 20 can be made by using 2 notes of 10. After which we will be left with no more sum to be created. Let us consider a larger test case, something of the kind 483. In order to form 483, we can use 4 notes of 100 denomination. We will be left with 83. After which we can use one note of 50. Then we will be left with 33. After which we can use 3 notes of 10. After which we can use one note of 2. And then we can use one note of 1. The total number of notes that were required is 4 plus 1 plus 3 plus 1 plus 1, which is 10. So this will be our greedy strategy. What we are going to do is find the number of times the maximum denomination can be used, and we'll use that many number of times this note, and we'll subtract the resultant value from our sum. After that, we'll try to find the solution for next value. Here we can use the note with lesser denomination than the previous one, because we have confirmed that no more notes of the previous denomination can be used, and we can use as many notes as possible. After that, we can use the same solution for the remaining sum. We can continue this solution till we have 0 remaining sum. So let's start coding the problem. First, we are going to take the number of test cases. Here we can work with integers or long. I would prefer working with long. We need a vector of all the denominations that we have in descending order, which is 100, then 50, then 10, then 5, then 2, and then a 1. Then we are going to iterate. Before that, we have to take the number as our input. We have initialized the answer as 0 already. Now I'm going to take and iterate through all the elements in the vector denom, and in the answer I'm going to take as many notes as possible for this note. After which I'm going to subtract the amount that is contributed by previous denomination. This thing will be n by. In the end, we will be left with our answer, and this answer will be our solution. While the solution is getting built, let us go through our solution. We have taken the input, after which we have written all the denominations in descending order. We are iterating through the denominations, and then we are trying to use, okay, here we'll get plus equal to. We are iterating through the denominations, and then we are taking as many notes as possible of the given denomination. After that, we are reducing the sum that we have by the amount that is already contributed, which is denom of I times n by denom of I. Okay, let us build the solution once again, because we have made a change here. Till that time, I'm going to fetch the sample input. We have a solution 1257. 1257. Let's try to submit the code. So we have submitted our code. Now let's wait for the result. We have got a correct solution. Thank you. Like the video if you understood the problem and its solution. In case of any doubt, feel free to drop a comment below. Do try to submit your own solution on CodeChef after understanding the tutorial. If you are interested in competitive programming or you want to master data structures and algorithms, CodeChef is the one place destination for you. We post many competitive programming concepts and problem-solving questions on our channel every week. To stay notified of the upcoming uploads, subscribe to our channel and hit the bell icon. Thank you.